Greetings. I am Madhu Kabra and I am currently pursuing Masters in Construction Engineering and Management from CEPT University, Ahmedabad. For this semester, the theme of the studio was Integrated Construction Practices, which focused on collaborative processes and use of relevant softwares to facilitate that, and tackling of modern day issues in the entire life cycle of a construction project. For this studio, the project we selected was a commercial tower located in Sargasan, Gandhinagar. The total civil cost of the project was 54 crores. It's a commercial building typology sitting on a site area of 1.47 acres with a total built up area of around 5 lakh square feet. The expected completion date for the project is 31st December 2026. The project consisted of 3 basements and ground plus 14 floor structure. For the scope of study of this semester, we have taken 3 basements, ground floor and first floor. The stakeholders involved in this project are the developer, the PMC, then various consultants such as architect, landscape consultant, structural consultant, green building consultant and MEPF consultant, and the contractor who is going to construct the building. The project was studied in groups of 4, where each member assumed different roles. My role was of an architectural consultant and mechanical consultant. 2D drawings were taken from the site and a BIM model was generated out of it based on our respective roles. The architecture model was developed till LOD 400 level and mechanical model was developed till LOD 300 level. Major hurdles that we faced in the process was that we didn't find uh, relevant details in the CAD to generate BIM out of it, and the lack of software knowledge. BIM models for all the disciplines were made, and then class detection process was run for each discipline so that a clash-free model was generated. After that, a quantity takeoff was done, which is basically a process to estimate the material, resources, and labor needed to complete a project. So for this, we have done quantity takeoff for architectural, structural, and all the services. As an example, I am presenting architectural elements here. The scope of study was first floor of tower A, B, and C. The quantity takeoff was done for walls, doors, windows, flooring, and cinder filling. The chart here shows the time taken in quantity takeoff process in manual versus Revit. If you see, the total time saved was around 6 hours by using Revit in quantity takeoff, and the total cost saved in quantity variations, which was there in manual versus Revit, was around 1,75,000. The major challenges we faced in manual quantity takeoff was errors in quantities which were mentioned in CAD, overcounting or omitting of quantities in the schedules. Drawings were not coordinated well enough to find the reference detail. Different nomenclatures were used between drawings, creating confusion, and overlapping of hatches in CAD which generated 2 to 3 times of the actual areas, and major variations in wall quantities because of beam depths which were not considered in manual calculations. The workflow on the top basically shows the workflow which we followed for taking manual quantity takeoffs. It involved a lot of juggling between software and a lot of processes which generated inefficiencies and mistakes. The challenges in Revit quantity takeoff we found were that we couldn't identify which material belonged to which tower, therefore contractor had to tag every element as per the building. This could have been improved if this process was involved in the BIM modeling itself. And the schedule showed both areas and volumes for each material, which was irrelevant. So for quantity takeoff, using BIM significantly improved efficiency and accuracy compared to manual methods. It reduced reliance on manual calculation and software juggling, saving up to 84% of the time. Additionally, Revit automates the and automated updating of schedules and quantities during revision eliminates the need for manual editing. The Last Planner system is a project management methodology that helps team plan and complete projects more reliably. It is based on lean construction principles. Last Planner system was implemented in two parts. One was for design activities, that is all the assignments and the studio activities which we undertook. And the second was site tracking. So we went and implemented Last Planner system on site we were assigned. So the table below shows the methodology in which we implemented Last Planner system. The tasks mentioned are all the commitments given by each stakeholder of the group. And then the dates were recorded, the commitment dates were recorded, and by the end of the week, the actual progress of the work was tracked. If there was a delay observed, then the reasons for delay were identified, and then the final PPC of each member was recorded. Few of the reasons of variance recorded were lack of clarity in the drawings, lack of knowledge of softwares, inefficiency in modeling processes, complexity of design, and incorrect estimates of time required to complete tasks by the stakeholder. So the PPC was recorded for 14 weeks and was mapped as shown in the graph above. Each each member's PPC is recorded and mapped here, and it was observed that in week 4, week 8 and week 11 there was a major drop in PPC. The major reason for this was lack of software skills. The reliability of architecture and structure consultant was steady throughout, averaging at 88% and 75% respectively. The average PPC of structure consultant was found to be low, which was around 57%, and the major issue was the severe lack in software skills. The graph below shows PPC versus reasons for variance. The bar graph indicates number of reasons of variance per week, and then the line represents the average PPC performed by all the consultants together. This graph basically shows the PPC trend, which tends to be higher where variances decreases. This tells us key management has to identify these variances and propose solutions to eliminate them. The average PPC also sharply goes down whenever there was introduction of new software assignment. So it again stabilizes as the member gets familiarized and with the new workflows and softwares. This slide shows LPS tracking for site execution works. The total scope of work which was observed by us was for 5 weeks and for two towers, Tower A and Tower B. The look-ahead planning was done sitting with all the teams on site, that is shuttering team, concreting team and reinforcement team. All the activities were mapped by each team and were put up as shown in the chart. In the beginning of week 1, it was committed that the completion of third floor RCC works would be completed by end of week 2. By the end of week 1, these activities were tracked. The slab and beam shuttering, staircase shuttering, column casting, and slab reinforcement was completed as committed by each team. But at the end of week 2, it was observed that the management shifted major workforce from Tower A and B to Tower C. So therefore, there was a shortage of labor for Tower A and B, due to which the casting of slab and beam had to be shifted to week 3 due to lack of resources. So therefore, our milestone of completion of third floor RCC works also got shifted to week 3. Ahead planning, daily commitment plans were made and were tracked for each consultant, and the chart as shown was started. The green line shows the PPC of reinforcement team. The PPC dropped in week 1 and in week 4. The reason was lack of manpower, as this manpower was shifted to Tower C. The orange line shows the PPC for concreting team. There is a lot of ups and downs, and the reasons identified was in week 2 there was an aggregate strike because of which RMC couldn't supply the concrete. In week 4 the RMC couldn't supply enough concrete as there was internal labor issues that was faced by RMC vendor. So it was identified that the project only had one RMC vendor. So it was suggested to PMC based on the data which we got from this chart that they should have a standby RMC team for the project in such situations. And one issue that was faced by all the team was labor shortage due to holidays that occurred during this period, that was Dashera and Diwali. So because of which labor left for holidays early and then they arrived on site late. This caused a major delay in and drop of PPC for all the teams on site. This also reflects in the graph shown below reasons for variance based on percentage share. This shows that 41% of the reasons of variance were labor unavailability due to untimely arrival or departure during the holidays. So a 4D simulation use case, we took one of the most complex part of our design, that is the architectural facade. So the complexity of this design lies in placing a lot of planter boxes that comes in the facade and which will have a lot of plants, and then having these expanded metal sheets in facade which is going to protect the building from harsh weather. So first we made a LOD 400 model of the facade as shown. So it starts with having C sections on the edge of the slabs and then having 8 MS plates placed vertically which are joined to the C section by cleats, and then the irrigation pipe is installed, after which the MS expanded sheets are then installed on the 8 MS plates. MS gratings are placed on the slab on top of which the FRP planter boxes uh, are placed. So during the 4D simulation of the facade, this was shown to the site personnel. They realized that there would be a space issue for installing the irrigation pipe after fixing the MS expanded sheet and the planter box. So this highlighted the need to install the pipe earlier to avoid complications. So this helped us revise the sequencing of the work where instead of irrigation pipe coming at the end, it was installed earlier in the sequencing, which will help the plumbing team to execute the work in a proper way. So making a video and showing this, making a 4D simulation and showing this to site personnel helps them give a better input to the management. So in conclusion, in quantity takeoff, the BIM simplified the accurate quantity takeoffs and saved time and energy while doing it, making it a valuable tool for contractors to enhance efficiency by using BIM generated quantities. In BIM modeling, creating of the project model while comprehending the various services it encompasses, while also effectively illustrating how different stakeholders collaborate and understand the need of a common data environment. The last planner system facilitated a deeper understanding of making commitments, identifying reasons for variances, recognizing constraints early, and applying insights for improved PPC and ongoing progress, facilitating continuous learning and improvement. In 4D simulation, performing a use case analysis of a complex design helped in better understanding of a project by all the stakeholders, helping them to provide more relevant inputs. Thank you.